Hi everyone, I hope you're okay. And I really hope that guys the videos will keep uploading and helping you out. This is the 32nd video guys, which simply means I'm doing question number 32. Please do expect a total number of 33 questions. Okay, I'm told that study the following incomplete equations for organic reactions 1 and 2. Compounds P and Q are organic compounds and T is an inorganic compound. Okay, so what's happening over there? Okay, let me draw a complete structural formula for this compound over there. Before I even answer the questions, I'm dealing with reaction 1. Let me write down reaction 1 here. I have CH3, CH, okay, let's do this. It's CH with the branch at carbon number 2, and then I have CH with bromine there, and then I have CH3. Let me just write the hydrogens over there. In the meantime, Bantwana Bam, I really hope you are subscribing, ne? Okay, plus a concentrated sodium hydroxide. Okay, so once guys I see a concentrated strong base, I will be dealing with elimination. I will be dealing with an elimination reaction. So what will happen here, guys? Since I have a concentrated strong base, it simply means I will eliminate a halogen as well as a hydrogen. Are you together? So I know that this will be eliminated. Firstly, before I even look at the questions, I know that this will be eliminated. So I want to know which one of the hydrogens will be eliminated. This one or that one. Whenever I'm dealing with elimination, I'm going to apply Zaitsev's elimination rule. Are you together? Zaitsev's elimination rule simply tells me that I will always take a hydrogen gas from the carbon that has the least number of hydrogens. If I can check here, this carbon over here and that carbon over there, this carbon is only bonded to one hydrogen, but the carbon at the terminal end is bonded to 3 hydrogens. So it simply means I will take this hydrogen and the bromine. Are you together? So whenever I eliminate these two, I'll end up having a double bond over there. Are you together? And then I still have my hydrogens. And then my inorganic products will be sodium bromide as well as water, H2O. Are you together? The Br and the OH will switch places, and then the OH will bond with this hydrogen to form H2O. So this is the complete reaction of reaction 1. Are you together? So compound P is a major product, and for us to form a major product, we followed the Zaitsev's elimination rule. Whenever we name this major product, we'll simply say this is it's 2-methyl but 2-ene. Okay, for reaction 1, we are reacting, for reaction 2 rather, this is ethanoic acid, ethanoic acid reacted with a primary alcohol to form butyl ethanoate. Are you together? The suffix butyl simply means that we used butane 1-ol. Are you together? We use the butanol, and all of the time, guys, for esterification, you will forever use a carboxylic acid and a primary alcohol. So our compound Q is a primary alcohol which has 4 carbons on its parent chain. So that's basically H okay, and then my final product will be butyl. It will be butyl ethanoate, ne? Okay, let me start with the acidic part. One, two, three, four. Plus water. H. So these are the complete reactions, guys. Before I even start answering the questions, I know that I have my complete reactions, and this happens in the presence of a concentrated sulfuric acid. Always the time, guys, ne? Esterification happens in the presence of a concentrated sulfuric acid. Okay, for reaction 1, firstly, I'm supposed to write the type of reaction that takes place. I did say that this will be elimination reaction, and the type of elimination reaction is dehydrohalogenation. This is elimination, and the type of elimination is dehydrohalogenation. Okay, and the IUPAC name of compound P is methyl but2-ene. Okay, that's 2-methyl but2-ene. Okay, name or formula of compound T. T just represent water. That's H2O. Okay, and then for reaction 2, they want us to write the 2 conditions needed. Firstly, we need a concentrated sulfuric acid, and then secondly, we need heat. Okay, the structural formula of compound Q. Compound Q is a primary alcohol that has 4 carbons. We did say that compound Q is just butane 1-ol. Okay, now let's go to the following question. We are told that the cracking of a long chain hydrocarbon that has 10 carbons and 23 and 22 hydrogens, the IUPAC name of this compound is decane. Decane, it's an alkane that has 10 carbons. Okay, the cracking of a long chain hydrocarbon, which is decane, takes place in a tube in tube A as shown below. Cotton wool soaked in this decane, okay, and then we have our catalyst over there. Okay, and then that's test tube B. Test tube B, I believe they are reacting the product of cracking with bromine water. Okay, let's see what's in the two straight chain organic compounds X and Z are produced in test tube A according to the following balanced equation. Okay, state the function of before I answer the questions, we are breaking down C10 H22. We are forming for cracking, guys. The definition of cracking is whereby you break down long chain hydrocarbons into smaller useful hydrocarbons of alkanes and alkenes are together. This type of cracking is called catalytic cracking because there is a presence of a catalyst. there are two types of cracking. There's thermal cracking and catalytic cracking. Né? For catalytic cracking, you'll obviously need a catalyst and heat as well altogether. But for thermal cracking, you only need a high pressured area and heat. Okay, let's break down this compound over there. Usually the one that has a coefficient of 2 is usually your unsaturated hydrocarbon altogether. So in this question, guys, you are not restricted as long as you will be able to balance your equation, and please make sure that you have an alkane and as well as an alkene altogether. So this will be C2. This can be C3H6. I already know that on my right hand side I have 6 carbons altogether and 12 hydrogens, which simply means I'm only left with 4 carbons and 10 hydrogens. So this would be one form of cracking that can take place. Né? Another one, you can form these results. You can form C2H4 altogether, and then the other products will just be C6H14, like this. Everything is balanced. I have an alkane rather, and alkenes altogether. You can choose which reaction you wanna go with altogether. I prefer the first one. Né? So structurally, no, I don't have to draw the structure. It will be too big. Yo. Okay. State the function of a catalyst in a test tube. The function of a catalyst, guys, is always to always speed up the reaction altogether. It speeds up the reaction by taking an alternative path with a lower activation energy. Okay, the organic compounds X and Z are now passed through bromine water at room temperature in test tube B. Only compound X reacts with bromine water. Compound X will react with bromine water. Why? Because compound X is our alkene altogether. Alkenes will react with bromine spontaneously, but for alkanes to react with bromine, it needs energy altogether. Why? Because alkanes have stronger intermolecular forces than alkenes, so they will require more energy for the bonds to be separated and stuff. Okay, apart from gas bubbles being formed, state another observation in test tube B. Obviously, guys, whenever you add bromine water, whenever you add bromine water into your hydrocarbon, there will be some color change altogether. There will be some color change. The test tube will start to look brownish altogether. And then write down the type of reaction that takes place in test tube B. Test tube B, I'm taking C3H6. I'm reacting it with the bromine. Plus Br2. What will happen over there is that these two bonds will separate. This bond rather will separate over there. This one will separate, and then we'll end up having Br and Br. So the type of reaction that takes place over there, guys, is just addition reaction. I'll have a Br there and a Br there. This is addition reaction, and the type of addition reaction is halogenation. The type of halogenation reaction is bromination. That's addition you can write halogenation, or you can write bromination. Okay, write down the molecular formula of compound Z. The molecular formula of compound Z. This is our compound Z, right? So our molecular formula for compound Z will be C4H10. And then they want us to draw the structural formula of compound X. This is our compound X. We've already drawn the structural formula over there. Let me write it. H. That's prop 1 in. Are you together? This is the answer for 4.2.5. That's how, guys, we're supposed to tackle this question. I really hope the video helped you out. If you have questions, guys, please don't be scared to write on the comment section. Or if I'm sorry, Tata Land, I never goes.